Okay, guys, so you made it back, and we are taking up the series where we left off, collecting the data, storing, communicating using RF and Wi-Fi. So let's go ahead and look at the communication of the data between the RF radios that we introduced in the first part. All right, so let's go ahead and just dive right into it. And in this case, we're going to be visualizing the data on the LCD screen as a review. Okay, so this is what our setup looked like last time with the nano sender with the DHT11 sensor and the Uno as the receiving MCU. Alright, so let's look at what the idea was. A nano in the warehouse would send the data to the MCU in the office building, which was the receiver. Both of them have radios, but only one of them has the sensor, which is the sender, obviously, the one in the warehouse. Alright. The code was basically this, if you recall. So here we have the sensor. So this is obviously the nano, the sender. And we reviewed most of this code before. And the slave address was important because it needs to be the same as the slave address that you're using in that receiver. So we'll make sure to check for that. And then in the setup, we initialized our objects, the serial monitor, the DHT, and the radio. And then in the loop, we basically checked for the interval. Every time the interval completed 1 second, we would call the send function. It's a very common way of timing tasks in programming. And the send function was basically read the sensor, write that data to the radio, and print some evidence of what's going on in the serial monitor. So this is basically what was happening on the nano sender side. We don't want to change anything on that side just yet. What we want is to visualize the data over here on the left side, which is where the office building is. So in our receiving side, we're going to include the wire library, the liquid crystal I2C, and the liquid crystal I2C object. And it's basically using an LCD with a different protocol, not the parallel protocol that we are used to, which actually uses quite a few pins and wires. In this case, we are looking at the I2C protocol for communicating instead of the parallel one. Okay, so we'll look at the difference, which basically reduces the number of pins and wires needed to connect the I2C to the MCU. But it's quite useful when you want to save up on pins that you need for other stuff. Everything else stays the same. The SPI, the NRF libraries, the CE and CSN pins, as well as the slave address, which, as you can see, is indeed the same one. Okay, and let's move over to the setup. As you can see, it is the same, except that we've added LCD init and backlight. And then get data, the loop stays the same. Get data also stays the same because there's no need to change anything for now. However, let's scroll over here to the show data, which is where we actually want to do something. Instead of just printing it out in the serial monitor, we want to see the data on the LCD screen. So in the show data, we're doing the same as before, but we are adding the LCD set cursor and print lines to make sure that we print humidity and temperature on the first row, humidity, second row, temperature, and then set new data to false as before. Okay, so this should give us our data on a nice LCD screen, which is a lot more comfortable and more practical than the serial monitor. Alright, so let's look at what this shows up as, and there it is on the screen as promised, 19 and 30. And you can add some placeholder labels there to make sure that what somebody's reading, make sure that he knows that 19 refers to humidity and 30 to temperature. You don't want to mix those up. Alright, so this is really quite simple. We didn't add a lot of code, but we now have access to the data on the LCD. And in the next video, we're actually going to be looking at Wi-Fi. So it's a type of radio, but in this case, we're using Wi-Fi to connect to the internet. So we're going to want to understand the ESP8266 module, how it works, how it connects to Wi-Fi, and how it can be used to send data. because once we have received the data on the MCU side, we are going to want to post it to the cloud for storage and analysis. Okay, so I hope you enjoyed this video, and don't forget to like, share, and subscribe, and we will see you guys in the next one.